But then it was like when I went to Europe is when I started picking up like, oh, there's some really nice things about Europe, right? So UK
Right.
was like the starting step, but like living in London after like a year, you just feel so like claustrophobic, right, and congested, and like so that kind of pushed me out of UK and then into Germany. But I mean, yeah, like Germany, I enjoyed for sure.
Welcome to Hakam Inspire. Today, our guest is Dr. Asif Jamil, who's a researcher in neuropsychiatry. He completed his BSc in neurobiology, MSc in neuroimaging, and has 2 PhDs, one in systems neuroscience and the second in rehabilitation science. He's also recently completed his postdoctoral training, and his research focuses on development and application of device-based, non-invasive neuromodulation to treat human neuropsychiatric disorders. He's recently been appointed in September 2021 as a faculty member of Harvard Medical School, as an instructor in psychiatry, and a principal investigator at the Department of Psychiatry at Massachusetts General Hospital. Dr. Asif Jamil, thank you very much for joining us. Welcome to the podcast.
Jazakallah for having me, and thank you for inviting me. Yeah.
So, Dr. Asif, we're going to talk about brain states, what the brain goes throughout our life. And, you know, we want to ask you loads of questions, especially in terms of improving our brain states as well. But just for all of our listeners, what are brain states, and how are they impacted throughout our life, throughout our day as well?
Sure. So, we know like in every moment of our life, our brain is always kind of engaged in some kind of a mental state. And, fundamentally, when we think about it in terms of neurobiology, we can kind of classify brain states kind of in two ways. So one is a conscious state. So in other words, what's our brain doing, that we are actually aware of. And these can include things like our emotions, things that we are feeling at that moment, whether we are hungry, we are tired, and so on. And these definitely have an effect on our brain state. Then there's, of course, unconscious states in our brain. And these are things that are always in the background, but we're not acutely aware of in the moment. So things like, our general belief system about the world, our intentions, our life goals, all of these things are working in the background, and they're influencing our brain, at any given moment. So when it comes to actually studying the brain, I mean, that's like the psychological, theory of brain states. But to study it, it's quite difficult with the available tools that we have. And kind of what we've relied on so far is this technique in neuroimaging called functional magnetic resonance imaging, or fMRI. And kind of the breakthrough study was about 10 years ago here actually in Harvard by Dr. Thomas Yeo and his colleagues. And what they found was, they took a large sample, over 1,000 healthy adult subjects, and they put them in the scanner, and they had them perform all kinds of different tasks, either, doing some kind of motor task or visual task, but also during rest. And when they studied the brain activities in these young healthy adults, they found that by and large, there was a very consistent pattern of, fundamental brain networks that always kind of appeared, something about 17 or so. And these are what we call now like functional brain networks. So they're just patterns of brain activity that kind of show up, whether we're, daydreaming or whether we're engaged in a task, and they kind of span different key hubs of the brain.
So it's 17 of them.
So that's kind of the number that they've, were able to cluster down, and they were able to kind of identify with, with more or less high similarity between adults. Yeah.
So just want to kind of get into that a little bit more. So can you expand on that and tell us a bit more about that? Because are these patterns seen with, do they vary with different kind of states of the brain? Do they vary with our mood, our emotions? Do they vary with sleep as well?
Absolutely. Yeah. Good question. So, these brain networks you can kind of think of as kind of like the main, ingredient, if you think of like a food recipe, right, you have like main ingredients that make up of a dish, but of course there's other things that you add in. You add spices, depending on how the way you cook, you end up with the final product. So these brain networks are kind of the fundamental constructed architecture of our brain. But then there's other things that influence those brain networks. And, like you mentioned, our mood, our emotion, our prior history in life. But also, there's things like, chemicals like neuromodulators, which play a huge role. And then, of course, there's like the daily changes in our brain state that are driven by like our circadian rhythm, that are driven by our hormonal cycles, and these definitely all are external factors which all influence our brain, and fundamentally they kind of influence our conscious state, right? Like these are ways that we can actually think about consciousness as well, like how is our awareness or how is our experience of life as a whole.
I think one question would be, we have all these different brain states. You're talking about all these effects as well that affect the brain. How important would you say these different brain states are for us throughout our life?
Yeah, so the thing about brain states in general is that it's always good to think about it in terms of what's actually normal, right, and what's not normal. In a normal healthy adult, we experience a different range of emotions throughout our day. We might be happy, we might be stressed, we might be tired, and then of course there's also life that's happening in front of us, right? Like we have our challenges in life, we have work, we have to take care of our kids and so on. So the thing about being able to control our brain state is actually very important, because it's kind of what we call in neuroscience cognitive control, right? Our ability to dynamically and flexibly change our brain state in order to do different tasks at once, but also from an emotional control point of view, not to just always be locked into a certain emotion, but to actually be able to modulate that.
Sure. Is that neuroplasticity, or is that completely different?
Yeah, no. So it connects with neuroplasticity in a way that if we are, if we're actively engaged in a certain task, if we're always, for example, if we're trying to learn, there will be activity in the brain which will be, driving that learning process, which is what we call neuroplasticity.
Sure.
But neuroplasticity is, it's kind of a principle which governs learning and formation of memories in the brain. And this occurs, of course, during the day, but it's actually more during the night, like when we sleep, when neuroplasticity is actually kind of what we call consolidation, which happens during sleep, actually.
Let's talk about that. So we're talking about sleep. Let's go kind of in a typical day. You wake up in the morning, go about your day, and then at night as well. So how would brain states change throughout the day, and what implications would that have?
Yeah. So in terms of thinking about our day-to-day, or moment-to-moment fluctuation, so the important thing to know is that the body as a whole is governed by cycles, right? So we have the cycles that are in the universe. We have the rotation of the sun, and we have the rotation of the spinning of the earth, but also we have these cycles in our body, and these are what we call circadian rhythms, right? These cycles which change our level of alertness, change our level of arousal, and in fact it's even mentioned in the Quran that it's actually a sign of Allah, that he says, surely, I've given you night and day as a sign, and sleep and specifically as a sign. So in other words, this all kind of aligns together. The way that we sleep at night is kind of correlated, with the rotation of the earth. And then when you look at it biologically, there's these, specific chemicals which are driving our circadian rhythm. These include things like adenosine, melatonin, but also internal changes in our body, like our body temperature, which, this fluctuation of our body temperature, which promotes our ability to sleep at night. And so all of these external factors are kind of what drives this, rhythmic oscillatory, mechanism of sleep and awake.
So if we kind of apply that to a practical sense, particular individuals suffering with insomnia, or even healthy individuals who do shift work, they may work nights, and as a doctor as well, you're changing pattern of shifts and things. So what's happening to the neurochemistry there, and how disruptive is that going to be to your brain states?
Yeah, good question. So, this is a kind of a common thing, where a lot of people, they say, like, I work better during the nighttime, so, they tend to stay up all night. Some people say, no, I work better in the mornings, like very early hours, like 4 a.m., 5 a.m. So fundamentally what happens is that, there's this thing called chronotype, which is kind of embedded in our genetics. And this can also be adaptable as we change our body, our routine, and so on. And These chronotypes are kind of what govern our body's biological clock. So, sometimes if you have people can be classified as early birds. Some people are kind of classified as like late owls. And these are fundamentally driven by how our body's genetics and specifically our chronotype determines our activity level. So now you mentioned people who are awake at night performing shift work. So of course, you would expect that after you perform such late night activities, you would go home and you would go to sleep in order to kind of recycle and kind of rejuvenate your body's biological clock. But what actually happens is that nighttime is kind of a little bit detrimental. So one thing we know from now neuroscience and biology is that exposure to sunlight and exposure to, like, doesn't even have to be sunlight now. We've seen also artificial lighting, which can even have the same effect. It's actually influencing also our body's exposure, our body's receptors of melatonin. And melatonin is a very key chemical, which is kind of involved in our sleep process as well, our ability to fall into sleep. So it's quite hard. I mean, people try now to, kind of compensate for that by taking melatonin as a supplement. A lot of controversy around if that really actually works or not. But in general, like there is definitely a reason why like humans kind of evolved to, sleeping during the night and then doing activities during their wakefulness state. Yeah.
So generally as well, just from a day-to-day perspective, it's wise not to turn on the lights so much at night. Phone use, everyone uses phones
Exactly.
at night on television. So yeah, it's quite hard in modern day society to.
Yeah, exactly. I mean, I think now there's this research coming out that shows, even I think Apple like designed specific filters for tablets and iPhones, which start to emit less and less like this blue light, which is what they think is like the frequency, which is really affecting sleep. And no, it's absolutely right. It's definitely wise to start shutting down your electrical devices, as we approach our sleep time, because these definitely have a detrimental effect on our sleep quality.
It's incredibly interesting. Just in one of our episodes, we had Dr. Hassan Khan, who's an ophthalmologist, talking about blue light and kind of in agreeing with what you're saying there, that towards the kind of nighttime, it does kind of stimulate certain receptors in the eyes and therefore the brain. And even Huberman's, Andrew Huberman on his podcast, he's mentioned quite a bit about the importance of sunlight in the morning and how that kind of stimulates brain states. I just want to get into sleep a little bit more. Essentially, in the context of modern science, how well understood is sleep? And are there any particular ways in the future that we can kind of better map sleep to understand it a bit better? I know you talked about sort of functional MRI in the beginning, but are there kind of efficient methods to get a deeper look at what's happening inside the brain when we all go to sleep?
Yeah, great question. So sleep is something I was, it's one of those early topics that really kind of even drew me into the field of neuroscience because it's such a wonder, right? It's such a phenomenal process. Like, all of a sudden we're awake and then we're conscious and then we just go into the stage of just being completely unconscious, being unaware of what's going on around us. And then we wake up and we feel kind of completely normal. So this is a very puzzling question in the field of neuroscience, like what's actually happening. So there are some things that we know now about sleep. The first thing is that sleep by itself is kind of considered a very restorative process of our body. So it's a way for our body to, rest, but also for our brain to think about, like everything that happened during that day, what information, does the brain need to actually hold on to, and what information should it try to forget? So all of that is actually happening during sleep. And a lot of these studies, like in order to understand what's happening in the brain, we've had to rely on animal studies mostly to understand that, because for human studies, it's very difficult to really get into the brain, especially in awake, or in this case, a sleeping brain, and try to understand the physiology. So animal studies is where we got most of the information. What are the neurotransmitters that are released during sleep, and how are these like chemicals in our brain changing and kind of helping the brain with this restorative process. So the main thing is that we have these different stages of sleep. So when we normally enter sleep, we enter what we call light sleep, which is considered like stage 1. And this kind of early light sleep is what, it kind of gives rise to, our first stages of feeling, in some cases, we start to feel or experience a little bit of dreaming as well. But during the later and later stages of sleep is when most of the restorative processes start to happen. So stage 2 sleep is when we start to have these things called sleep spindles, which are these like very fine electrical signatures in our brain's electric activity. And these sleep spindles are what we think is happening when our brain is trying to kind of reconsolidate its motor memory. And then more deeper into sleep is when we have what we call stage 3 or stage 4. And this is kind of characterized by what we call slow wave sleep. And in slow wave sleep, we have like, it's even very clear to see in humans, we have these like things called very slow brain oscillations. And what I mean by that is when we record electric activity from the brain, we see, very smooth up and down cycles of brain activity. And what we think is happening in this very deep sleep is also correlated in some ways with states of unconsciousness in patients, is this concept of bistability in the brain. So the brain is kind of alternating between periods of on and off, on and off, on and off. And in this very deep sleep state is when, we also have consolidation of our memories. And then from that stage, very deep sleep stage, we progress into what we call rapid eye movement sleep, or REM sleep. And REM sleep is kind of, a lot of people already know, is when you have these rapid left and right eye movements.
Yeah.
And that's when we think we're getting most of our dreaming. We're experiencing a lot of visual hallucinations, very, rich sensory information. And REM sleep is also a kind of a state of the brain where a lot of memory and learning is forming. But it's also a way for the brain to kind of go under, what we might consider therapy, right? You're experiencing all of these intense emotional stimuli. At the same time, our body is kind of paralyzed. Our entire muscle system gets kind of shut off at the brainstem. So our mind is experiencing everything, At the same time, the levels of epinephrine are also getting decreased, so that we're not actually feeling emotion. We're not experiencing that emotional effect. We're just kind of seeing it, and it's a way for our brain, our mind to kind of reconcile like those emotions and those events into our long term storage.
I think the natural question then would be, how much sleep do people actually need? And this is a huge question, which everyone's asking. And is it? There's always this element of duration and quality.
Exactly. Yeah. That's a good question. So what we've started to understand now is that it's not always the length of sleep that's important. So having 6 hours of sleep versus having 8 hours versus having 10 hours, that's not going to be a big difference. Of course, I wouldn't recommend somebody to sleep all day. That's definitely not going to be helpful. But what we do know is that it's actually the quality of sleep which is important. And not only the quality, but when we think about the timing, it's also consistency, which is very important. So there's been a lot of studies done now showing that, there was a study even here at Harvard where they took a bunch of students and they, right before they were about to take an exam, they tried to ask them, like, how is your sleep quality? How's your sleep duration? And what they found was that the best predictor of performance on the exam was not the duration, but it was actually consistency in the sleep quality. So sleep quality, what I mean by that is, when we talk about our different sleep stages, the important thing is to make sure we're getting enough of the deep sleep. So the stage 3 sleep or stage 4 sleep that I mentioned, because that is what is really going to, consolidate our memories and so on. But another thing is and we see this now in a lot of psychiatric patients, is kind of reducing the amount of times we are waking up in the middle of the night, or what we call arousals, which can actually end up fragmenting our sleep and then causing a lot of problems the next day. And so, both of these things are important, consistency and sleep quality. So I would definitely recommend, for those students out there, make sure you're being consistent. And one more thing I would say with respect to the time is that we have now some research showing that there seems to be an optimal time duration. So we think now that like an interval of around 90 minutes seems to be a very key or very important time interval. So 90 minutes is about the time when we complete one complete sleep stage cycle. So stage 1, 2, 3, and then REM. And normally now, I think even some smartphone applications are starting to build this in. They try to wake you up, as an interval of 90 minutes.
I've got one on my phone. I've got one on my phone as well, and
great.
It actually works really well. So you can actually,
oh really? Oh
yeah,
wow.
you can actually, well, from my experience and a couple of friends who have used it, you can actually, so you just time it, in 90 minutes, and then you do it tells you the kind of target time that you should be going for. It'll round it up or down 15 minutes or half an hour. And yeah, for me, it's worked amazingly. You just wake up fresher. That's how I feel, and you don't have that grogginess about when you wake up sometimes in the middle of your sleep and you don't feel good. So yeah, I've used one of those apps, and it definitely works for me.
Yeah, exactly. And I mean, it just goes to this principle of, rhythms, right? And like our biology is really kind of governed by this like rhythmicity, and this rhythmicity just doesn't even happen over a large scale, but it happens even in very, very smaller time scales, right? The way our brain is working, it's kind of very fascinating. Like the rhythmicity of our brain is actually what's causing communication between different parts of the brain. The way that the neural activity fires, whether it's low frequency or high frequency, these all kind of govern the electric principles of our brain's communication. So yeah, I mean, it's very important to think about rhythms, when we think about our neurobiology. Yeah.
Yeah, no, I think that is interesting. I mean, Fatah's mentioned the app. I've recently seen my fitness band started tracking my sleep there, but I don't know how accurate these things are at the moment. But they do tend to kind of give you an idea of, how many breaks in your sleep and what time you've woken up and things. I think having a chat with you has definitely shown us the importance of sleep and getting good quality sleep as well. I just want to focus on kind of brain states in the day. Quite often, we've seen that kind of sleep has an impact on your productivity and your ability to focus in the day. But how can we better optimize our daily routines to ensure that we do achieve kind of the tasks that we set out to do, and we're not kind of wasting our day, and also keeping our mental state healthy?
Yeah, great question. So this is kind of a question that's really been, getting explored more and more recently. This whole concept of like, neurohacking, like, how can we kind of hack our biological clock? So we've already seen, there are some cultures in the world like which try in some ways even, naturally to kind of take advantage of our biological clock and kind of synchronize their day-to-day activity around that clock. For example, I know in Japan, there's kind of a tradition where, after lunchtime, the Japanese workers will take a 20-minute nap and then come right back to work. I mean, Japan is a very kind of an outlier when it comes to
Yeah.
productivity. The amount of work that they're doing there, it's just unbelievable. And then, of course, there's like these tropical countries like Spain where, they've also kind of built this culture of, taking a very long siesta, I think that's what they call it, around lunchtime. So I think the thing that we've kind of started to understand is that this biological clock, our circadian rhythm, and this like specifically this 90-minute what we call ultradian rhythm, seems to kind of be also involved during the day-to-day life, during the day or during our wakefulness state. And so there is some research now showing that if you kind of time your activity in 90-minute intervals, that might actually, be beneficial. Like there will be this period of high productivity, at the end of 90 minutes that'll kind of taper down. And so it's kind of recommended to, not do like a burst of activity at once, but, take these kind of short pauses. And then another fascinating area of research now is like in this area of taking power naps. So, I mean, this is also kind of very inter-individual. Like I know like my older brother, he'll just take a nap, whenever you can even ask him, he'll just take a nap. For me, it's very difficult to sleep
get
during the
into
day.
that,
Yeah. So it's very heterogeneous, but in general, what we've seen is that especially in some of the research in my previous lab, that if you take around a 20 to 40-minute nap, that can have a very, very enriched and very restorative effect on your day. And even in some ways, it can be kind of similar to waking up in the morning where you feel completely alert and active. So, think about these things like, timing your work, not doing everything at once, but also taking advantage of the clock. And then, of course, also we should think about the time of the day, right? So where our body is kind of, in general, more alert right after we wake up in the morning, that's when our level of adenosine, which is this receptor which kind of builds up during the day, is at its lowest. So in the same way, we have less sleep inertia, and therefore we feel more energetic. So doing our important tasks earlier in the day for sure is going to help. Studying, especially earlier in the day, it's definitely recommended. So these are just very general core things that we can kind of work on.
I think it was interesting you mentioned that a lot of cultures and religions, of course, have taken this on, and actually napping was also a practice of the Holy Prophet Muhammad, peace and blessings of God be upon him as well. He used to take midday rather, naps as well. And of course, it's also, I think, going forward when science advances, and especially for Muslim researchers, there is an element within Islam of actually waking up in the middle of the night and doing tahajjud as well. So that it would be interesting. It sounds counterintuitive to your sleep, but of course, we believe as Muslims that Allah is, of course, the creator of the human mind as well. So it's not going to be something which is in the long run bad for your health. So it would be interesting to explore that route as well in the future, of course. And this is something, a call to Muslim researchers, of course, to kind of see the different elements within the Islamic way of living as well.
Absolutely. I mean, when we think about our 5 daily prayers, and especially like you mentioned, our tahajjud prayer. So, like I mentioned, this concept of rhythms, right? Ultradian rhythms, and, doing things in interval. So it's very interesting the way, our Islamic day-to-day principles and lifestyles kind of also trace back to the way our brains work, right? So I mentioned already, working in cycles, but also the way our memory works as well. It's already been shown that, in order to develop plasticity or in order to develop memories, simply just stimulating neurons, for a long period of time, it's not going to really establish that connection. It's the rhythmicity, like, we know already, even at the level of cells, that, the neurons have this refractory period where it takes time for the neurons to come back, close their sodium channels before it fires again. So yeah, that's one of the things in neuroscience as well that we know. And, doing prayer, doing salat, I think besides the spiritual benefits, there's a lot of biological or neurobiological, psychiatric benefits as well, which I would be happy to go into. But I mean, that's all kind of more related to our emotions, our level of satisfaction in life, and yeah.
Yeah, let's bring in kind of this element of mood and emotions. I think that's a huge part of our day-to-day routine, happiness, sadness, anger, depression, anxiety, all these things, they kind of tie in. Tell us about the neurobiology of emotions, what's happening in our brain, the kind of chemistry side of things, and perhaps if kind of techniques on how we can better control these emotions to prevent either prevent psychiatric disorders like depression or anxiety, or prevent ourselves getting into those kind of states.
Yeah, that's an important topic for sure. So we know that, when it comes to emotions, the way our brain kind of is handling or, processing emotions is kind of a cascade of neuroprocesses, right? So, at the first level, we have what we think or we call sensation. So the information that we're getting from our environment around us, what we are seeing, what we are feeling, what we are hearing. And as that information enters our brain, then we have this process of perception, so how do we actually make sense of that sensory information? Once we perceive that information, that then goes into our thoughts, right? So how are we thinking about what we are feeling? And then ultimately those thoughts are what drive our behaviors. So when it comes to happiness, sadness, anger, all of these things are, kind of modulated at each of these different steps. So, you mentioned, how can we think of, regulating our emotions, and then, how that might apply to some of these pathological states. So, our understanding of the neurobiology of emotion is still very, at its elementary level. It's kind of very complex in terms of when you think about psychiatry. There are some, some developments which I've been working on in my lab here, which focuses on certain brain circuits, which are what we think might be driving certain characteristics of depression. So what we're doing is we're looking into the concept of emotional states, so positive emotional states and negative emotional states, and how we can, identify the biological circuits. And some of the research we found is that there are, going back to the concept of brain networks, there is like a brain network which we think is kind of somehow involved. There's a region in the brain, in the kind of front of our brain called the prefrontal cortex, which is connected to a region kind of more in the midline and then deeper, which we call the anterior cingulate. And we think that the connection between the prefrontal and the anterior cingulate might be a very important connection that might be overactive in patients with depression. And these two brain areas are, they seem to be responsible for, on the one hand, processing emotion, and then on the other hand, being able to modulate or change the brain state. And so the research that we've been trying to kind of do is try to disturb that, what we think is as hyperconnectivity, through external stimulation, and hopefully try to see if patients are going to rehabilitate from that. We do see some very beneficial effects, but the problem is that even with pharmacology, psychotherapy, and even the stuff that we're doing, which is neuromodulation, these effects are very short lasting. And so, 6 months later, 8 months later, patients tend to relapse and then they come back. And then, we are still back to stage one.
So on that, sorry, you're saying, through pharmacology as well and these different techniques, there is the relapse. But if we backtrack, and also after the treatment, what effect is modern life having on depression, anxiety, on these moods? How could someone prevent themselves going into those states for a long term? Of course, we all experience, sadness, depression, anxiety, but they shouldn't be overtaking our life. What kind of tips would you give for people to regulate their moods, and also, if they've gone through treatment, stay out of falling back into that depression?
Yeah, for sure. So one thing that we know is already there is when it comes to individuals, of course, prior history is an important factor. What kind of led you to that moment, your childhood, or events that led you to having, very deep levels of depression or anxiety. So, our childhood, our environment plays a big role. Especially now, we've seen that there is this been huge spike ever since COVID, with depression and anxiety, which seems to be kind of related to our change in our environment, right? We're not able to socialize as much with others. And instead of socializing or going outwards, we're kind of going more inwards, right? We're kind of developing these addictions, whether they're to substances or to products like technology, cell phones. And this is kind of at the biological level affecting our reward circuit, right? Our dopamine's reward circuit. And as soon as this cyclical process just starts getting more and more pronounced and more aggravated, we start to kind of lose our contentment in life then, right? We start to lose our feeling of happiness, our feeling of joy, because we're just locked into this very singular reward pattern.
Yeah.
So I would say to reestablish that healthier mood, the first step would be to kind of think about how we can rewire how our brain thinks about reward. So instead of doing, these superficial activities, think about more productive activities, learn a new skill, learn a new language, develop some physical skills, maybe become more healthier, and so on, which at the end of the day is what's going to give you a longer lasting feeling of happiness. So another issue I think is also kind of related to psychology, which is we're seeing now more and more younger people are developing what we call this internal locus of control. And what I mean by that is that, our younger generations are starting to think more and more that the outcomes in their life are driven only by their own actions and not through any external factors or events. And this is in contrast to an external locus of control, where people believe that no, not all of my actions are due to myself, but there's other factors which may have been responsible. And so having a more external locus of control is actually more healthier, right? Because it gives us a bit of more a feeling that, not everything, and in fact, this is kind of going back to religion, that not everything we do is in our control. There's some external factors which can play a role in our future. And in that way, having spirituality is a huge, huge benefit that we have, especially when we think that, when we see in Quran, especially that there's verses that say, well, we know already that God is the best planner. Right? He, nobody can kind of come up with a better plan than him. But it also says, that, I don't have the verse, but to lose hope is also to lose faith in Allah, right? So,
Yeah,
having
Allah
that
says,
faith,
the people who aren't hopeful are actually disbelievers. So
exactly,
like they don't have true belief in God.
exactly, yeah. So, and having this hope is a very important thing, and I think it's also important going back to patients with depression and anxiety. One of the things that we've seen is that there's this thing called the placebo effect in pharmacology, where people, even, you tell them or you give them a pill which has no active substance, like, it has, sugar or something. They take that pill and they actually start to feel better. And, this is also true for neuromodulation studies. We give them, instead of giving them electric stimulation, we give them fake sham stimulation. And about 20% of the patients come back and they feel better. They feel like there was an effect. And some research now shows that there are changes in the brain which might be driving this placebo effect. So our prefrontal cortex has these pathways, what we call top-down control, which starts to cause changes more deeper in the brain, changes in neurotransmitters, and these end up having a therapeutic effect. So it all goes back again to having hope.
There was this really interesting element which I learned from Dr. Andrew Huberman in his podcast, where he's talking about the belief effect. So it's not necessarily placebo, but it's the belief effect that people who believe that stress, for example, he did he was explaining a study on stress, and those people who believed that stress was bad for them, it was affecting their health, compared to those people who thought that stress was actually a positive thing in life, and it was, it would help them go through life. It wasn't so negative on their health, and actually, it mattered, because the people who did believe that stress was bad for their health, their health did deteriorate compared to those people who didn't think that stress was so bad on their health. So it's super interesting, and true what you're saying, that the belief element is so important.
Yes, yeah, absolutely. I mean, I would be interested in knowing more about that. I mean, it's all of these things I just kind of been thinking about in passing. But definitely, the concept of belief is very important, especially when you think about psychiatry and contentment of life. Yeah.
Let me just ask a quick question about sort of, it's in relation to the research you're doing in terms of neuromodulation. So from what I understand, you're giving short amounts of electrical stimulation to stimulate certain pathways in the brain. Correct me if I'm wrong, but is there also an element where by performing certain actions, you may also activate those pathways? I'm thinking more along the lines of, for example, there's a hadith, saying of the Holy Prophet, peace be upon him, who mentions that you should try to smile. And there have been various studies that, by performing a particular action of smiling, it stimulates certain pathways in the brain. So I'm just trying to kind of link the two elements together, whether there's an actual link between your actions, and by performing certain actions like praying 5 times a day, which is prescribed in Islam, whether that can be a sort of a protective factor against these kind of depression, anxiety, psychiatric illnesses.
Yeah, no, for sure. Well, we know already, like, the way our body performs actions, our external environment. the body has a huge effect on the brain. Like it's not just a one-way street; it's a kind of a two-way street. So you mentioned the study about smiling, the hadith about smiling, and I thought of this study. It was published some time ago. I forgot the name. And they did the study where they took healthy people, and they had them put a pen in their mouth, in order to kind of show this, like, mimic like the experience of smiling. And they studied their mood for the next 6 or 7 hours, and they found that like having this just facial expression caused a lot of changes in the body, and feeling happy and feeling already like positive. So definitely, like the way we perform day-to-day actions, our daily activities, have a huge effect on our mindset and our brain state in general. And if we so if we then think, you mentioned in the beginning about stimulation. So we for sure doing activities, doing certain activities repeatedly over and over causes also changes in our brain state, which is kind of the reason also we are kind of instructed to do namaz or pray 5 times a day. And if you kind of think back to Islam, we and kind of link, there's a lot of parallels actually, the way our neurons form memories and they form connections. The same way, we are forming a connection with God through our praying. I think there is a hadith Qudsi where it says that, if you take 1 step to God, God takes 2 steps towards you or 10 steps towards you. And if you start walking towards God, God starts rushing towards you, right? So in the same way, when our neurons are forming connections with each other, our first connection, when we're much younger physically, it's those connections are much more easier to form, right? Like our brain is more plastic. But then as we start to get older and older, it becomes a little bit more difficult.
Yeah.
Nevertheless, if we get older and we try to remember some of those memories, there's such an intense brain activation that the brain tries to really work hard to kind of reestablish that connection. So in very similar ways, I think like the way we think about our connection to Allah, it's saying, Allah says that, just take even 1 small step towards me and I'll do the rest, very kind of inspiring, when you think about it that way as well.
No, that's really interesting. And all the different researchers, at least the Muslim researchers who we have on the podcast, a lot of them are saying that as they go about their studies, they're just seeing so many different links as well. And I think a lot of Muslims and religious people in general are now beginning to see, with advancements of science, that what they're doing is actually protective, or it's actually good for their health, in terms of prayers or the different traditions that we have in religion, especially. So it's really interesting. And I guess the question which I want to ask is, how, in your research, in your studies, you've done 2 PhDs, you're doing amazing work in Harvard. What impact does reading the Holy Quran have on your research or your line of thought, if you like?
Yeah. So, Quran has been, like from a very early age, I remember, anytime you read the Quran, you just get so much inspiration. It just opens the possibility of the world around you. You just start to even look about creations that Allah made in a very different way. So one thing that kind of really stood out to me when I was, doing my studies early on, I was doing some research during my bachelor years about insects, and specifically about the hearing of the praying mantis, which is this this insect which kind of looks like this, really green, and it has its hands like that. And we were studying the ear of the praying mantis, and we found that the ear is a very, very sophisticated ear. it's able to hear frequencies that are far above what our human ear can pick up. But the ear of the praying mantis has been evolved, especially in order for it to detect the ultrasound of bats, right? So, which is its main predator. And when I started looking into it more, I found that the praying mantis isn't the only insect which has developed this very sophisticated organ. It's actually shown up many times before in evolution, and then that kind of I remember reading this book, Revelation, Rationality, Knowledge and Truth by Hazrat Mirza Tahir Ahmad, and in there he kind of really goes into detail about what are the different creations that God has made, and how is it possible that such very sophisticated organs have been developed multiple times throughout evolution, and independently from one another. So that kind of really inspired me that there definitely must be something more to all of this, right? And then more recently, as I was doing my research, especially when it comes to psychiatry, I know there's a hadith, and I don't know the exact wordage, but it says something along the lines that Allah has not made any disease for which He also made a cure, right?
Apart from death.
Right, exactly. And and then that kind of really inspired me to continue with my research about electric stimulation, right? Because electricity is kind of the very principle of the way neurons work. And by tapping into, this very natural thing that we already have in the world around us, perhaps that could be one way that we can think about how to try to, alleviate some of the pain in our brain.
No, that's really interesting. I guess it's been a really interesting conversation. I'd love to have you back on the podcast as well, and explore so many different elements. Yeah, no, and I guess the final question which I want to ask you spoke about religion, Islam, the Quran, your research. There's a huge element of atheism in the modern day society, and I guess because of a limited amount of scientists, at least getting a lot of the media attention, there's been this thought that all scientists are atheists. I want to ask you: has going into science, you've done multiple PhDs, you're doing lots of great work in research, has that increased your belief in God?
Absolutely, it has. And it's kind of more not just belief, but it's also like trust that I've had now. That anything that you really put your mind to, and you forget about like what's going to come later. You just put your faith in God that what you're studying or the pursuit that you're trying to follow, ultimately there is a higher being which is going to control you or control your outcome. That's been really inspiring. But in general, we think about atheism. The kind of problem of atheism is not that they actually believe that there is no God, right? They don't just believe that there might not be a possibility of God, but they flat out reject God. And for me, that's just completely mind-boggling, right? Like if you were to tell someone like all of this stuff around you just came like from nothing, right? That's scientifically even that's just absurd, right? So I've never felt any kind of inclination to even going in that direction. It's just been kind of more the opposite way, more
That your
strengthening. Yeah,
your belief in Allah and
exactly.
trust in Allah has
Right.
increased. Dr. Asif, Jazakallah, thank you very much for joining us all the way from the USA, of course. And yeah, we really look forward to having you again, having you on the podcast again.
Jazakallah, and thanks for having me. And you guys are doing a great job. So keep up the good work.
Thank you for listening to the Al Hakam Inspire podcast. We hope you enjoyed it. Visit our socials on Instagram, Twitter, and YouTube at Al Hakam Inspire. And of course, subscribe to our YouTube channel and leave your comments there. We would love to hear your feedback and thoughts, so send us an email to inspire@alhakam.org.